Okay, we have been spending some time now considering different types of combination problems with repeats, and we've devoted several videos to this subject matter now. Each video tries to consider a problem that's progressively more complicated. Incidentally, if you just found us on YouTube, if you will go to the website at digital-university.org, all the videos concerning permutations and combinations and probability problems, they're all listed there for you in their proper sequence. Okay, this is probably the most difficult problem that we're going to consider. And here we're saying, suppose we have 4 different types of cookies, and we're going to fill a bag, let's say with k number of cookies, but we have these constraints now. If there's going to be any vanilla cookies in the bag, it has to be an even number of them. If the bag is going to contain chocolate cookies, there has to be a multiple of 5. And for each bag, there can be at the most 4 ginger cookies, and at the most for each bag, 1 raisin cookie. So subject to these constraints, what are the number of ways that we can fill a bag with k number of cookies? So you can see that with this problem, it is a repeat problem because each bag can contain multiple cookies of the same kind. But there's no way that we could possibly approach this problem with the formula that we had derived in the past videos. This formula, where n is the number of objects that we're choosing from and k is the number of selections that we're making, this doesn't even apply. This problem is much too complicated for this kind of an approach. The only way that we can handle this then is to use generating functions, and the way we set it up is just like we did in the previous videos when we had simpler problems. For the distribution of each of these cookies, we try to describe that with an appropriate generating functions. So let's start with the vanilla cookies. Now each bag, it might not have any vanilla cookies, but if it does, it has to be an even number. So it might be 0, which would be x to the 0, or might be 0, which would be x to the 0. Well, that's just 1. So it's 1 plus, can be 2, can be 4, it can be 6, and so forth. And we're not saying explicitly right here that there's a limit as to the number of vanilla cookies in each bag, so we just let this run out to infinity. For the chocolate cookies, there might not be any, which would be x to the 0, or 1, or there could be 5, which would be x to the 5th, or there could be 10, or 15, and we're not stating any restriction as to the number of the chocolate cookies, so we can let that just run out to infinity. For the ginger cookies, there can be at most 4. There might not be any, which would be x to the 0, or 1. There might be 1. There might be 2. There might be 3. But here now we're putting a restriction on it. At most 4. So here we stop. This is not an infinite series, unlike the situation with the chocolate and the vanilla cookies. And for the raisin, there can be at most 1. So there might be 0, which is x to the 0, or 1, or there might be 1, and there's no more after that. So again, we have this restriction, so this is not an infinite series unlike for the chocolate and the vanilla cookies. So those are the different generating functions that describe the distribution for each individual cookie. Now, to consider the situation for all of these, we have to multiply all of these generating functions together, and then when we do that, we're going to ask ourselves, well, what is the coefficient of x to the k? Or if we were saying, how many ways could we fill a bag with, say, 30 cookies, then we would be asking ourselves, once you multiply all these generating functions together, what would be the coefficient of x to the 30th? We multiply these together. Here we're going to leave it open-ended and just say x to the k. Now, as you might imagine, multiplying this infinite series times this infinite series times this would be horrendously difficult. So, first of all, let's recall from the earlier videos that 1 plus x squared, like this, and so forth, this is equal to, where this does continue on out to infinity, that equals 1 over 1 minus x. Well, if we had here 1 minus x squared, then that would equal 1 plus x squared plus x squared squared plus x squared cubed, and so forth. Like this. So for the vanilla cookies, that generating function we can write like this. One over 1 minus x raised to the second power. And likewise, if instead of 1 over 1 minus x squared, we had 1 over 1 minus x to the 5th power, then that would be 1 plus x to the 5th plus x to the 10th plus x to the 15th plus x to the 20th plus x to the 25th, and so forth. So this generating function can be written like this. So now, for our answer, we have to multiply these two together. This we can't simplify any further. That's just 1 plus x. Now, what about the case with the ginger cookies? Here we have 1 plus x squared plus x cubed plus x to the 4th, and it stops. We can put this in a better form to work with by doing some simple manipulations. Remember that 1 over 1 minus x, that equals 1 plus x squared plus x cubed plus x to the 4th, and it continues on the way on out to infinity, like this. Now, where it gets interesting is, what happens if we multiply both sides of this equation by 1 minus x to the 5th? So you multiply this side of the equation by 1 minus x to the 5th. Then we have to multiply this side of the equation times 1 minus x to the 5th. So let's just do it then. 1 times all these terms, we'll divide all these terms out again. 1 plus x squared it gets tedious, but we don't want to make any mistakes. Like this. Now we're going to multiply all these terms by minus x to the 5th. That times 1 is minus x to the 5th. This times x is minus x to the 6th. This times x squared is minus x to the 7th. So you can see that when we multiply by this, all these terms hereafter cancel, and we have 1 plus x squared plus x cubed plus x to the 4th. We have that finite sequence. So this generating function we can write like this as 1 minus x to the 5th divided by 1 minus x. So let's make some space. Now, what we want to do is multiply this times this times this times this, and then we want to find out, when we do that, what is the coefficient of x to the k. So, here we have 1 minus x squared times 1 minus x to the 5th times 1 minus x to the 5th divided by 1 minus x times 1 plus x. Now we've multiplied all these generating functions together, like this, and let's see what it gives us. These two terms will cancel, and then here we have 1 minus x squared, here we have 1 minus x, and here we have 1 plus x. Here we have a difference of 2 squares, so this can be written as 1 minus x times 1 plus x. That's this term, so let's rewrite that. 1 minus x times 1 plus x. And here this cancels with that. So we multiply all the terms together, we have 1 over 1 minus x times 1 over 1 minus x. So that's 1 over 1 minus x, quantity squared. So we multiply all the generating functions together, what we end up with is 1 minus x to the minus 2. And we were concerned ourselves now, okay, in here, what is the coefficient of x to the k? And here then, let's make some room. This is now where we make use of what we did in the previous videos of how to handle the binomial expansion when you have it raised to a negative exponent. We know that in general the formula is this binomial coefficient, which is just 1. We write it like this so it's easier to remember the pattern. Like this times x. And remember, this continues all the way on out to infinity. What's of interest for us then is that the coefficient of x to the k is, it has to be, the number here has to be 1 less than this. So this would be n plus k minus 1. This number is 1 less than this one over n minus 1. And we have all these other terms. But the coefficient of x to the k is this right here. Okay, let's take a look at this. For our problem, remember, we had 1 minus x to the minus 2 power, like this, so n equals 2. The minus sign is already here. So here we have 2 minus 1 is 1, so we have k plus 1, and 2 minus 1 is just 1, so that right there is the coefficient of x to the k. And this is k plus 1 factorial divided by 1 factorial times k factorial. And this just equals k plus 1. So there it is, the number of ways that we can fill the bag with k number of cookies is k plus 1. That's the coefficient of x to the k. So for example, if we said, well, we want to know how many ways can we fill a bag with 20 cookies subject to all these constraints, the answer would be 21. So this is a demonstration then of how powerful generating functions are in solving complicated problems. Now, sometimes what happens is when you multiply all these generating functions together, you get a very complicated expression, and you might have to do some manipulations on it in order to determine the coefficient of x raised to a certain power. And how you handle that for some of those difficult cases is what we'll consider in the next videos. So come back and join us for those videos, and we'll try and solve some more problems.